Okay, thank you very much. And I will follow up from Dieter's talk, I think in a relatively smooth way, by making a lot of the same points, a lot of the same messages, but in a very different way, from the perspective of land use, and land use being in between the physical dimension of the land cover, the vegetation on the earth's surface, and the social system, the people deciding on what to do with the land use in producing food, getting fuel, and all other decisions related to that. So I will very much take a socio-ecological systems perspective. But also, I would like to start a little bit of debate, going back to this point of this safe operating space of the Holocene. While we can debate about how stable that has been in terms of the climate, but at least it's not really an option in terms of the land use. The Holocene vegetation state is not an option in a world with 10 billion people that need to be eating something. So in terms of vegetation and land use will be in any future state being far out of that Holocene space. So there we need to be much more creative as a humanity in how we ensure that the vegetation that we have is supporting the biophysical and biochemical processes that are needed to support this Holocene climate state, but being at the same time in a very different state than the Holocene vegetation. So that makes it very different from the climate system in terms of that we cannot aim for a Holocene vegetation because we have a lot of people. So that's a starting point of my discussion, and that makes the discussion relatively different. But in that sense, land use, and I titled it, is a huge challenge because we cannot have this Holocene state because we have to feed people, but it's also a land of opportunities. And I start with coming to a paper that a lot of you must have seen early this year, and a lot of people have commented on, is this paper. It was written by a group of ETH scientists, basically showing land of opportunity. We have the opportunity to use land to solve our climate problem. Just plant 1 billion hectares of trees and we can sequester a lot of carbon. And the main message they had, by 1 billion of hectares of canopy cover, we can capture so much carbon that will solve a lot of problems. Now that's the land of opportunity that we have. But of course, we've seen a lot of comments on it. First, the calculations were not completely correct. They didn't account for albedo and a lot of those aspects. But what is more interesting are the comments that came that talk about the competing claims of the land. Again, coming to the interactions between the different planetary boundaries, the different elements we're having. And a lot of those comments were not new. This huge potential of the land is not a new thing. This is an old map that was getting a lot of attention a few years ago, published by the World Resource Institute, IUCN, and so on, showing this huge potential for landscape restoration, large areas. And this map doesn't differ so much from this reforestation map. It's basically the same map. And also this one, already years ago, got a lot of comments. And one of the people that also commented again this time was Veldman, and he wrote this first map already, this from a biodiversity perspective, a paper that called The Tyranny of Trees in Grassy Biomes. Because he said, yes, replanting a lot of those areas that are on the map is wonderful to sequester carbon, but these areas are savannas, open, grassy landscapes, and if we want to keep that type of biodiversity, we should keep those open. Now, it's a very interesting debate, because a lot of those grassy biomes are currently kept open by human fire management, by human livestock raising. In the past, some of these were kept open by big grazers, elephants, and other things, but also that has been very much dynamic in the Holocene. Sometimes these were more tree-based biomes, sometimes these were more open biomes. Now they are largely human-managed open biomes, but they they inhabit quite a lot of biodiversity. So it's trade-offs. You can use those lands to sequester quite a bit of carbon. Even in spite of all the uncertainties in their calculations, planting trees is a good thing to get carbon out of the atmosphere. But it is having a trade-off on biodiversity. The other big comment that came out of their calculation is that they said they excluded agricultural land. But what they did, they excluded arable land. And a lot of agricultural land is basically grazing land around the world. Sometimes open plains with very sparse grazing, sometimes intensive grazing areas. So if you would reforest those locations, you would have to go to completely stall-based feeding systems. You would have to change diets and other things. And in a lot of local societies, people are dependent on these type of systems to, for their food supply. So again, reforesting those areas would have a trade-off on other things. The bottom line is we do not have a lot of available land around the world. Almost all lands are providing functions for biodiversity, for all kinds of agriculture. And we can do maybe more clever on those, but there is a huge competition. We want a lot from the land. We want land for food security. We want land for climate mitigation. We want land for biodiversity conservation, for recreation, for economic development. We want to have green cities rather than ugly grey cities, but they take more land. We want to have better infrastructure and so on. And there's a lot of people that want land to speculate about, to invest into, because of this competition. Land increasingly gets higher values. So there's a lot of competing claims. And those are those interactions between the different objectives that we have, between these different planetary boundaries. Sometimes they are synergetic. Some reforestation can be good for biodiversity, but the best reforestation for climate mitigation, for carbon sequestration, are fast-growing plantations, not really the best for biodiversity. So there's trade-offs between a lot of those uses. Let's look at some of those trade-offs in more detail. And I'm going to one dimension, the urban dimension, that is in a lot of the land cover, land use change models, the integrated assessment models, that is not taken into account. Because in terms of land use, urban areas, 1 to 2% of the Earth's surface, depending on how you calculate, that's a small part. And I will show that these are important. Or maybe these dense urban areas are only 1% of the Earth's surface, so not very much. There is also a lot of areas in between. And a lot of those lands that are urbanized are our most productive farmlands. Because historically, where did people build a city? In an area that could supply good food for the city. So often in delta regions, best agricultural lands were the center point of the cities. So urbanization, and here just a picture from Osaka, I think in Japan, where we see the urban encroachment on this intensive vegetable farming and slowly disappearing the farming and being taken over by urban area. But it's not only the urban area itself. Surrounding urban areas, you see recreation development. You don't only see the compact thing, but you also have a lot of wealthy people affording some green living, taking a lot more space for housing than the urban dense areas. Horsification, horsekeeping. If you go around big cities in Europe, and you will see agricultural land. But if you see what's on the agricultural land, it's hobby horses. City people renting the land to have their horse there. These all used to be agricultural productive lands and are no longer agricultural productive lands. And if you make some calculations on a global level, we can see that the picture of this 1% impact is changing. First of all, if we look to those urban areas, the dark green on the bars there, in 2000 and in a model projection for 2040, we see that indeed there is a lot of spatial variability, but overall it's just a few % of the land area. If we also include those peri-urban areas, the not so dense urban areas, this area is getting already a lot larger, covering a lot more of the Earth's surface. But still, like in Europe, up to 10%, maybe going to 15% in the future. So that's already significant. In other world regions, still a lot lower. Now if we make the calculation, and now we're going to look at the red bars of all land where you can do agriculture, then we see that this is exploding. The areas covered in the future by urban areas are taking a very significant fraction of our agricultural lands. Now, how do we deal with that in a land system, in a global land system? We lose production of agricultural goods around the cities. Now, we have a nicely globalized system of food trade, so what we do is we import from other areas. And that's often areas that are less suitable for agricultural use, because the best lands are already used for agricultural use. So yields will be lower than what is lost. So the compensation of newly reclaimed areas is larger than what we lose here. So you can see that if percentage are going up to 20%, and we have to compensate that from more marginal agricultural lands, large areas of the globe need to be converted to agricultural land to compensate for these urban areas. So although it's only a small fraction of our Earth surface, this urbanization makes through all kinds of indirect connections, and because of the geography, it's not a global averaged system. No, the best lands for agriculture are around the cities. Because of that spatial diversity, the impacts are a lot larger than we would estimate at first hand, based on a simple percentage. And that also makes difficult questions. This is one I always ask to my students, starting this talk. Which city you think is more sustainable? This nice green one or this gray, very densely populated one? They all choose for the green one. But then if you start the calculations on how much land you need to have the same amount of people living there, and you take the land take that it would take for having those type of cities, you get to a different answer. So these are very complex questions, trade-offs between different land systems that you can choose, that you have to calculate through to the global system, even through food imports. And this is connecting green city development towards Amazon deforestation in the end. So that's the systems approach of looking at local land uses. Now this is from the climate perspective towards land, and a very well-known graph. I probably don't have to explain this one, but for me as a land use researcher, it's one of the most scary graphs that is there. Because what we see in this graph is basically to stay within our planetary boundaries. We'll keep using the language after Dieter's talk. We'll have to follow those blue emission pathways. All of them not only going to zero emissions, but going to negative emissions. What are our main pathways for having negative emissions? That's sequestering carbon, either through reforestation or having biofuel cultivation and capturing the carbon and storing it afterwards. That's basically the two largest viable options for efficiently getting negative emissions. Both of these options take land. And we're already in a crisis of losing too much of our forest land through agricultural expansion. And now we get the climate perspective saying, oh, we also need some land. And for biofuel, we are in Europe very fastly trying to replace our coal energy generation by biomass. And biomass needs to be cultivated somewhere, taking land. And there have been a lot of studies of trying to grow biomass on available land, whatever we call available again, often being some degraded or marginal lands. But it's still a fact that also biomass and biofuels have the best productivity at lands that we also want to use for agriculture. You need fertile soils with enough water to basically also produce lots of biomass. So we're competing basically for the same lands as we're competing for in our urban development, as we're competing in our food system. So competing claims there. And because of these connections, these kind of simplifications of the system also become often a reality, because it's the same lands that can be used for the different uses there. Now looking at the food system. And the food system, if we look from a long-term perspective, let's take again a Holocene perspective. Humanity has worked miracles. If we look at the amount of food we have available, the choice of food items, and the population we're able to feed, more or less, and there are still people not having enough food. There's also a lot of people having far too much food. We have worked really miracles. Nobody thought in history that we would be able to feed so many people in such a way across the globe. So that's a big success, but a success with several trade-offs. Partly the success is because we have used technology to increase our production a lot. But also we have changed the food system very drastically from a very local food system, where even 20, 30 years ago, the amount of food that was traded of base commodities around the world was a very, very small fraction of the total food system. Nowadays, this has drastically changed, and a relatively large fraction of food is traded around the world, getting us very nice diversity of products. Think of what was the conventional food in Paris 2 centuries ago during winter. That was not very exciting, looking very, very different from this. That has been a huge progress. But the cost of that progress are things like this. Oil palm. And oil palm is an interesting one in terms of land use. It's an evil crop because it grows pretty well on areas that are currently peatlands or nice tropical rainforest with huge climate functions, huge functions for biodiversity. On the other hand, if we would stop eating oil palm and replace that by rapeseed, sunflower oils that we can cultivate here, we would need at least 5 times the area to cultivate the same amount of oil. Because oil palm is also a wonderful crop. It's incredibly efficient in producing oils, much more efficient than we can do in our climate in producing those things. So in terms of the total land used, it is very small as compared if we would do it with other crops. But it's a regional issue. We're now in a globalized system that we can use this efficiency of this crop to produce a lot of oil on a relatively small area, which wouldn't have been possible if we would have had to produce it ourselves within Europe. Another one, soybean, also a wonderful crop in producing proteins, but also one, again, growing in areas that we would rather preserve for biodiversity and climate functions. Also a rather evil crop in terms of its management system and other things. So yet another consequence of having a more globalized system where demands are put there. And just as an illustration, and coming from the Netherlands, I found this picture rather fascinating. Netherlands being one of the smallest countries of Europe, and this is a study where they try to basically, of the Stockholm Resilience Center Environmental Institute, where they traced basically where the soy cultivated in Brazil is ending up. Now, through all traders and importers and exporters, which have a lot of different names but are only a few companies in the end, a lot of it ends up in China. That's not surprising, and that has even increased since this analysis, because before a lot of soy for China came out of the US, and that was no longer possible, so now they even get more. But the second largest importer of soy from Brazil is the Netherlands, this tiny country. And I always ask my students the question, why? How can this small country import such a lot of soy, and much bigger countries like France? It's not even in the list here, it's somewhere hidden below. And I get these kind of funny answers, saying, oh, we have quite a lot of vegetarians in the Netherlands. No, not really. The other one that I liked a lot is, yeah, it's because of the colonial tradition that Dutch people like to eat soy sauce. Not really. It's, of course, the livestock industry. Netherlands being the largest dairy producer, basically producing dairy, drying it, and shipping it to China again, and other places around the world. So people are surprised at the moment that in the Netherlands we have a nitrogen problem, because what's happening, we import with the soy the nitrogen, have it transformed into meat and milk, and the manure is left in the Netherlands, and the milk and meat are disappearing to other countries. So you get a huge accumulation of nitrogen, which is now leading to a lot of farmer protests and other issues in our country. But it's an indication of this globalization of the food system, in which baby milk consumption in China is linked to the Netherlands, is linked to Brazilian deforestation. And I was yesterday having a phone call with a journalist, and he asked me, yes, this climate change things, yeah, now how serious are things really, and yeah, do you really think this will be a collapse for humanity, and what will happen, and who will be suffering, and what about the food system? Is that more vulnerable than in the past? And I found this a complicated question, because if we look back in history, there have been quite a lot of collapses of food systems locally, because of periods of dryness, because of little ice age, because of other events that locally completely created a disaster in the food system. People being hungry, having not enough food, and societies partly collapsing, but on a regional scale. Now we have a much more global food system through this global land use and all the connections. What happens now if Dieter's maps on the droughts that he indicated, they are happening very regionally around the world, also in the future? How will that affect the food system? Not only locally, because of all the connections, we will have a global impact on the food system of a drought in certain world regions. If Brazil, the soy region, faces a drought, there's no way that we can compensate for that in other places. So we'll feel it throughout the whole global system. But is that some resilience in the system now because we can compensate food flows from other regions because we have trade? Or are we more vulnerable because it's all connected? It is a complex question. A lot will depend on the scale of those climate disasters on the food system. But for sure, we'll feel it throughout the world, and not only locally. So that's a very strong difference, again with the past conditions in the food system, that we're now having a connected global system and no longer a localized system. Just some other graphs of showing how this has worked, already old graphs, but I think they're still nicely showing how much hectares of land are embedded in this trade of food, and how complex those are. Arrows going up and down between all kinds of world regions, showing that land use is very tightly connected to the system. And with water, the water system, going back to the water planetary boundary, it's relatively, a lot of the water has to stay in the catchment. You can transport some water through food and through virtual water trade. You can bring some water through irrigation system from one catchment to another one, but it's all a much more localized catchment-based system than the food system, which is strongly globalized and connected. So very strong differences between these systems. And even this is happening on the more social political side, is that countries don't like to be dependent on this. It's not nice to be dependent on a global trade system for feeding your populations. So that's why also in terms of owning the land and deciding about the land, people try to take control to ensure to have sufficient access to land resources even outside of their own country. So that makes land use also special. Land use is a global system. We have a planetary boundary for land use, 75% of forest, whatever that may mean in reality. But land is owned, or at least people have management rights individually on all small pieces of land. There's not one big person deciding about land use. It's decided by many different people. And this is giving challenges for the modeling of the land use, to which I will come in a little. Just another illustration and a little bit of a story of the difficulty. We go back to our planetary boundary of land use, the 75% of forest. And we go to the country of South Korea. South Korea used to be a country that had, it's a country which has a special topography. It's all hills and steep slopes. There's very little flat land. And it has a lot of people. So cultivating the land was difficult over there, leading to a lot of degradation in the past. At a certain moment, South Korea decided this is not working. We're going to reforest all those degraded lands, and they had massive reforestation there. And if we look at the maps, I think this is 1960s, this is current forest cover. They have really increased the forest cover enormously. And I was at the UN Land Degradation Conference in South Korea last year, and all of the high-level officials were praising South Korea for achieving that high amount of land restoration, fulfilling the planetary boundary of having 75% forest cover, and so on, returned in their country. Then I started Googling a little bit on what was the trade-off of achieving that. And that's, the country is only food self-sufficient for grains for 48%, but especially, and they are loving their meats and beef consumption, all animal feed is completely imported into the country, and even of the beef, they're only self-sufficient for 37%. So they import huge amounts of food from the world market. And that has been increasing incredibly, almost in a linear opposite way to their reforestation. Because if you reforest the land, you don't produce food anymore on that land, so you have to import it. So their big success, for which they are praised on reforestation, has come probably at the cost of deforestation in Brazil and other countries. So a lot of global trade-offs and land use. So should we really compliment them on reaching so nicely all that land restoration goals, while at the same time importing basically degradation and deforestation from other places? So the complexity of a lot of the connections between dimensions, they play out on the land, on how we decide about the land. In the end, the only solution is that we have to somehow navigate those trade-offs. And navigating trade-offs is basically partly saying, yes, there are trade-offs. If you want to increase your food production, it will, almost in all cases, come at the cost of biodiversity. Higher production of food will lead to lower biodiversity. But there is an option space again, and this is a different way of sketching this opportunity space as Dieter did. But you can do it in the best possible way, so you increase your production and you do not lose so much biodiversity, or you do it in a very bad way. You increase your production only a little and you already lose a lot of your biodiversity. And basically, it's our challenge to bring, if this is the current situation, try to move to that upper frontier to minimize the trade-off rather than to say there is no trade-off, there's just synergies and we can do whatever we want. We have to manage these systems. And that's, of course, a nice message and a positive message, so that's a lot of people pick that up, and that's why we have concepts like climate-smart agriculture, sustainable intensification, and also Dieter ended his story with showing this potential of some economic measurements. How can we do better by basically navigating those trade-offs. Sustainable intensification is mentioned in all the IPCC reports as a big option of achieving better things. And yes, it can be. If we look like at one of those measures, conservation agriculture is not plowing the land, but using mulch in between the crop as a way to basically get the best out of the system. Reducing evapotranspiration, reducing surface runoff, and getting more carbon into the soil, even positive effects in most world regions on the albedo. So you have a local cooling effect of doing this, also through albedo effects. So a very nice method. But can we apply that everywhere? Is this a solution? So what we did is first having a look at where currently do we find these management practices. Not so much, mostly in very large-scale farming systems where not plowing is a cheaper option, and in our not-so-nice soybean, choco systems with a lot of the Roundup type of farming where you control your weeds rather than by plowing by a lot of pesticides. But it is quite good that they don't plow because it keeps more carbon in the soil, but it has some other problems. Then we try to look at what other locations would it be possible to have those systems, because there's constraints. It takes new machinery, it takes capital, it takes a certain climate where you have advantages of having this mulch layer. You cannot do it in all the climates. If it's too wet, it gets one big rotting mess on the soil. So we gathered from literature a lot of factors that are either excluding the use or limiting the adoption of these measures. And then we got, there it is, two scenarios of where possibly you could expand. And we see that it's not possible in all the agricultural areas around the world. There's big constraints of doing that. So the potential that is calculated, like in the IPCC reports, of such measures is in practice similar to this reforestation potential, a lot lower. We have too high hopes in those nice synergistic solutions. But even in those places where we can adopt these measures in a feasible manner, if we look in detail, there's another story to it. And this is a very simple calculation. For Africa, we took the areas where it would be possible socially to adopt these conservation agriculture practices. But then we started calculating what's the scope of soil organic carbon increase that you get, how much carbon can you capture by those methods. That depends a lot on the soil type you're having, the climate you're having, and what will be the impact on yields. Would it be a positive impact on yields or a negative impact on yields? Depends a lot on the type of crop you're cultivating. Some crops react positively on this no-till management, other crops are reacting with a lower yield because they are favored by the tillage management. And then we see a strong spatial pattern. The green areas are the areas where uptake would be a good thing, because in those areas you get a high soil organic carbon increase and you don't lose any yield by doing this. A win-win. But like in the red areas or in this corner, in those areas you have very limited positive effect on your soil carbon, and you have possibly a negative effect on your yields. So please don't do it, those solutions there, because it's a lose-lose strategy. So again, by accounting for the trade-offs in the spatial context, you learn a lot about where to target your interventions in the system. And then the areas where you can do this are much lower. If we would just implement it in all those colored areas, we made a rough calculation that we would gain half a gigaton of carbon by the increased soil organic carbon sequestration. But because of the lower yields and we need to reclaim other areas, we would lose again almost half a gigaton of carbon due to increased deforestation. So a huge trade-off and not a lot of gain. So again, playing with the trade-offs in a spatial way is important. So trade-offs are often spatially variable. They often affect different sectors, services, stakeholders, can be a source of conflict. They can be minimized if we do the science right and do not believe too strong in high hopes of options, but do more precise work by targeting our investments, taking the right message. And we should be very careful. That's where I started also already with the reforestation example, but the sustainable intensification is another one of those. Not to overestimate the benefits, but be more careful about it. In the end, also the trade-offs require choices. We cannot have it all on the world. The highest level of biodiversity, the highest level of food production with our diets that we like to have with all the climate mitigation. There are trade-offs because land is a scarce resource. Now very quickly, I will show you very little bit about modeling land use, because there's a lot about modeling in this workshop, so I want to go very quickly through it in terms of land use. Modeling and land use can have different objectives, and this is a graph from the IPBES assessment where we show the different types of land use modeling that can be used. Starting with the traditional exploratory scenario modeling that we also know from IPCC is basically, this is the current land use of Brazil, how could that look under an SSP2 scenario in the future? So scenario, straightforward, exploratory, predictive modeling. But then there's also other types of scenario that are more trying to help us design how do we reach our goals? How do we reach this planet within the planetary boundaries? So how do I end up where we want to be rather than what will the future be like? It's a different question. And I will give you one example. What we did is collecting from all kinds of policy documents what targets concerning forest, reforestation, land degradation have been agreed upon by the Convention of Biodiversity, in the SDGs, by the Convention to Combat Desertification. So we have this whole list of semi-quantified targets that are set. And then we thought, how would the world in terms of land use look like if we would reach all those targets? So we configured our model not only by saying we should have a certain amount of food produced to have a certain amount of consumption, but we also said you have to reach all those targets. You have to sequester so much carbon. You have to restore so much tree cover. You have to do this and to that and to do that. That's what we gave to the model, and then the model started to calculate. We started with food demand from the business as usual, the SSP2, and we put in all those targets that are already agreed, and then the model was, after a few hours, said, sorry, no solution. It doesn't fit. And we thought, okay, maybe we ask a little bit too much of the world, given all those competing claims. Let's then take the SSP1 scenario, more sustainable diets, lower food demand, and we put the model again, and yes, it found a solution. This is what the world could look like while reaching those targets under an SSP1 scenario. I will go up and down, and what you'll see, it's a greener world. But you also see much more of those orange colors, dark orange colors, which are the more intensive agricultural areas. So restoring land and reforestation of goals, as already basically agreed, would be only possible if at other places we intensify our agricultural production a lot. There are some nuances. In some regions it can be reached by kind of multifunctional agroforestry type of landscapes, but in a lot of regions we see this very strong intensification of agriculture happening. It's a very different outcome if you compare it with a standard SSP2 scenario. A lot nicer. So it helps us depicting how would a world look like in terms of land use if we meet those goals. So it's a very different type of modeling than just running scenarios. This is also more seeing, okay, we set the goals first and then we see what world would fit those goals. Then I will skip this one and show you another thing. A lot of other models are based more on scenarios which are evaluating specific policies. What would happen if we would change this or that? And for that, here, going to the UK, Devon, nice landscape with cultural heritage, nice tree lines and parcels that are degrading. And our question here was, what happens if we would change these policies? If we would decrease the environmental scheme payments and liberalize the land market? So we made a model with very different representation, really representing the land market, representing the demography of the farmers that are selling and buying land, adopting or not adopting environmental subsidies, and seeing what would happen with the quality of those hedgerows under such scenarios of having a non-liberalized market with a lot of subsidies or a very liberalized market. The interesting thing is that there is a lot of variation, that even under this protection scenario, we see areas where we see a decrease of landscape quality, and we see areas with an increase of landscape quality. And we could do that because we represented the diversity of decision-making of different farmers, of different landowners. People are not the same around the world. And that brings me to the different types of modeling. There's a big argument for saying, because of this variation in decision-making, we have to represent that in our models, because it's humans that decide about land use. So we have this notion of multi-agent models where we really present this decision-making in the model by really saying it's not just driving forces leading to land change. No, there is an actor in between, a decision-maker, and we have to put that in our modeling. So we really have interactions between people and interactions between people and the environment in the models. So you get these kind of representations in your model. You have the ability and willingness of decision-making, leading to options, decisions, and actions influenced by other agents, social networks, and institutions. A very complicated representation, but a representation of the real decision-making that's happening on the ground. So we can do that, we can simplify that again by seeing groups of decision makers that have the similar type of decision making, modeling that, well, actually we have decision makers and decision makers linked to pieces of land where they make their decisions. Now, this is very nice to do on a local scale, but how to do this on a global scale modeling? Because on a global scale modeling, we have lots of people, they all make different decisions, they come from different cultures. In all the big global models, we just ignore this, because how the hell can we do this? So we all assume, in all the big economic models, basically economically optimizing land use agents. Basically, everybody is just trying to maximize profit. We know that's not really the reality, but it's a simplification. But we know there's people that have different objectives, especially towards land use. Having as much livestock as possible, that's your status. It's economically not optimal, but it's your social status in certain world regions. There's prestige, there's environmental objectives that people have. What we try to do to bring this concept to a global level as a first attempt is by going through the literature of all kinds of anthropology and social science case studies where people document at a place how people make decisions. And then we did what some social scientists hated us for doing it. We said, we try to explain the way people make their decisions based on their context. So we regressed the spatial pattern of where we find a certain decision making on the environment, their market access, their soil type, their climate type, and so on. We got quite high levels of explanation. We could explain this variation in decision making pretty well, and then extrapolate it to a global map where it's likely to find a certain type of decision-making in land use. And this is now a basis to advance the social side in all of our decision-making models to see how can we represent this diversity in decision-making of people that decide about the land in land use models. So this is really bringing in the social into the modeling, but it's still a big challenge to go beyond adding complexity to already complex integrated assessment types of models. I think this is where I will stop. I will quick a little bit of questions, a little bit of slides here. I presented too much. But coming to some conclusions, because I gave my messages already with some longer stories on the earlier slides, that land use is a place where a lot of competing claims in terms of our objectives that we want to have play out. Also, climate mitigation has to go a long way through the land use. Trade-offs are there. We shouldn't ignore them. We have to make choices, and we have to navigate them. But trade-off means dealing with decision making with individual landowners. Land is owned by people. Land is governed in very complex ways. There's laws, there's land use planning, and there's local decision makers. We cannot simply say, let's reforest a large area, because it's owned by people that live on the land. Models can help us to explore the options. Models can help us to better understand the decisions that are needed, but it also needs representing the people. And that's quite difficult, because a lot of social scientists work on a very local scale. We often like to work on a global scale, because we're dealing with planetary problems, and there's a huge gap in between those two scales. And that's why I showed this first attempt of trying to bridge those gaps in better representing land use as a socio-ecological system in Earth system modeling. Thank you.
Yeah, thank you very much, Peter, for this great talk. In the beginning, you mentioned the paradigm again with this notorious Bastin paper. It's good to plant a tree because it takes carbon out of it. Yeah. If you want to make the climate warmer, do it. I mean, if you plant a tree in Siberia, it takes carbon out of it, but you warm the climate. So it's but I haven't seen so many comments to this paper, and there was one specifically by Friedlichstein and others warning against such papers. They are really dangerous. I mean, they come up with some solution here, plant trees, and it's okay. But you mentioned this already.
It's the big message, but I also see a parallel even on the sustainable intensification. We should be as careful. It's with all the solutions. There are no easy fixes.
Precisely.
But it's still good. Even in Siberia, it may be good to plant a tree if you accept the trade-off that it's not solving your complete problem, but it may be good for the biodiversity there. So it may still be a good thing.
Okay, now questions, serious questions, comments. Yeah, sure, of course you can, Victor.
Peter, one of my colleagues from Institute of Geography in Moscow, he just analyzed a trend of abandoned land in the Northern Hemisphere, and he saw that generally over the 20th century there was a trend towards abandoned land in the United States, in Europe, in Russia. So I'm getting confused. Yeah? So there is a land which people don't use anymore because of economic reason. How this would fit into your first point that land is a scarce resource?
It's a very good remark. In most of the cases, and if we look to abandoned land, and let's look here in France, in the Alps and Pyrenees, we can see those areas where you see villages that are in ruins, and you see some stone walls still that were old field boundaries, and there's now some forest or shrubland on top of it. These were often relatively marginal lands that couldn't compete on the world market. It's easier. You cannot compete in the Pyrenees on a mountain slope in producing agricultural goods with the Chaco region in Argentina, where you have large fields and you can fly your helicopter to use some pesticides and so on. So a lot of abandoned lands were not having a huge contribution to food supply because they were more marginal lands. A difference has been Russia, because after the Soviet Union collapse, because of economic reasons and political reasons, a lot of the large-scale farming collapsed basically there on relatively good lands. A lot of it is now being recultivated again there. A lot of it is also owned by pension funds and others that speculate with their grain stocks on not cultivating those lands, so that's other drivers of things. But in the end, the amount of abandoned land that we see also in Japan and even in countries like Vietnam, where we say there is a forest transition going on, these were previously relatively shifting cultivation lands, and now often taken over by short-term forest plantations to provide wood pellets for our biomass burning. Maybe not a bad thing, there's more carbon in that than in some of that. For biodiversity it's another story, but those were very marginal for agriculture. And so we see concentration of agriculture on the global market. And
so let's say in short terms, you see that this trend will be reversed. So that
maybe not. We're not going to cultivate the peonies again, but it's now easier to cultivate the larger part. It's compensated by the deforestation at other places where it's easier to have large-scale cultivation, where you can compete on a world market. It's part of the change in our food system that you're now competing for the same produce on the world market, and then if you have marginal or difficult conditions, you see that, and that has caused basically the forest transition in Europe, where you see basically an upgoing line of the amount of forest, but that's compensated for by a downgoing line in the tropics. And that's the climate story. We rather have our forest in the tropics for the climate than in Europe, and that makes it again complex.
Further questions, comments?
There was an article recently in The Guardian in the UK where some local bovine farmers and their MPs were arguing that they're getting a hard time with this push for veganism, and there should be an analysis done to show that bovine farming is not as evil as everyone is making out. Have you done any sort of modelling in that regard to see how all of those results could change with more veganism or vegetarianism?
Yeah. We basically already, the simple analysis that I showed, that we couldn't allocate all our reforestation goals that are already agreed and which are not sufficient for our carbon and biodiversity objectives, already couldn't work with our current diet projections for business as usual. We would have to meet to go closer to an SP1 diet, which has a lot less meat than current diets. If you take it further, it's also partly, all the calculations that have been made on different diets are basically a message of hope, because in moving to less animal protein-based diets, we can free up a lot of land to support a larger world population, to support more reforestation, to support more biodiversity protection. We are using about 40–50% of our agricultural land area for livestock production, directly or indirectly. So that's also an enormous opportunity, that everything we reduce in our animal protein, we can free up some land and release some of the pressure. But on those arguments, partly they are right. In some places around the world, for local populations, livestock keeping is a viable resource of food because it's not so suitable for arable farming and other things. I wouldn't agree on the UK, but there's places where livestock farming can play a role. But we always have to acknowledge that livestock farming is, in terms of land use, a very inefficient way of producing food. And there is a lot of, in terms of land use, a lot to say, and a lot of evidence that it makes a big change if we reduce our animal protein consumption. It doesn't need to be completely vegan, but it's a direction, and at the moment we are on the different direction, and I think there's no contradiction in the scientific evidence on that.
Okay. Further, you had to come.
So So then quickly, any potential for vertical farming as a way to kind of mitigate?
Sure. It's again one of those things of high hopes on avoiding the trade-off, avoiding making choices, avoiding to really adapt the way we consume food, the way we transport ourselves, and so on. It's a technical solution with some potential, but not an incredible potential, because in terms of what you need to build for that, and the energy that takes, the emissions that takes, and so on, it's very difficult to operate it at larger scales. It is very difficult to do that in a efficient way because of all the investments and all complications of it. But it's for some specific systems, for some specific locations, yes, it can be to have some in large urban agglomerations where there is poor infrastructure outside or poor land outside of the urban area and you want to have fresh vegetables. Yes, you can use it in a good way, but it's a niche solution. It's not the solution. It can make a small contribution.
Now the final question, comment by Victor. Michael, first Victor and then Michael.
Okay, so I just want to ask you about models of land use, because this week in PNS it was an article by Palmer and Stevens published, who said that development of host system models is stuck because we run at the limits and it's just incremental progress, so we need really to go to exascale. So, and then they just, of course, have agenda that they want to push forward with high-resolution model. So, do you see that regarding land use models, do you think it's just progress is incremental, or do you think there is a need for kind of step or
let me even say, I think there's no progress on land use models at the moment. I had to write this year, I got an invitation to write kind of a paper on the progress of land use modeling, and I had a hard time because I came up with the same challenges as in a similar paper we wrote about 10 years ago, and the same challenges were still there. We have done on the biophysical elements, like in the vegetation models and LBJ and other models, we have done a lot on the biophysical side, a lot of maybe incremental but good improvements. On the social side of the land use decision making and getting the processes right of why deforestation is happening here and not there, we're far off. And I didn't show those slides, but if we compare the land use outcomes of different integrated assessment models, the differences between the models are a lot larger than the differences between scenarios of the same model. That's a little bit of a problem in our current IPCC approach of using a different integrated assessment models for the different scenarios. So we have still a huge problem there. The uncertainty is incredibly high, and we are not able to capture processes like this land grabbing, the whole conversion to value chain involvement with decision making and sourcing in different regions, which is determining a lot of the dynamics, the whole political economy and the whole social changes going from more local subsistence farming to market-based farming, and those transitions we cannot capture very well. I had a large research grant to try to do it, and I failed as well, because we are dealing with such a complex system and such a lot of lack of knowledge on how do people decide what they do on the land. How is land tenure arranged around different parts of the world? There is no map of what's the land tenure and land ownership status and who owns what land around the world, not even in a very broad sense, and that's hampering not understanding the social system is a big problem for advancing it. And in the end, we're dealing with a social system here around the world, and that's limiting progress. While we make progress on the biophysical side, we don't do a lot on the social side.
Okay, thanks. And final and question and comment by Michael.
Thank you. I liked a lot your emphasis on agent-based models in this context and on trade-offs, but you did hint at one point, you had the poster that, a plaque that said, biofuel, whatever. One of the worst miscalculations was this taking over of land from growing crops to growing biofuels. And there has been some literature which tried to prove that the ensuing famine, that killed quite a few people, was not due to that, but apparently it was. So I was just wondering whether you want to add a little bit to this particular issue in a mistaken trade-off.
I think this has been another example of having too high hopes on a solution. Biomass as being a solution, and being a nice one in terms of the whole economy and the business you can develop on that. So pushed by a lot of people, and in earlier stages also by scientists saying, and we still say it in our SSP1s, we still say we have to do a lot of biomass and carbon capture because that's the only option to get there. I think it's disaster. I think we give the wrong message even there, while we put some footnotes, they are ignored. And I hear politicians say, yeah, in SSP1, the sustainable world, there is a lot of biomass cultivation. I think it leads to incredible trade-offs if we're not careful. I've seen, it's a very difficult story how it works through the socio-ecological system again. I've seen it locally in Mozambique of farmers in a neighboring area getting a lot of benefits from a biofuel plantation next door because they can sell some sugarcane to get some cash and have labor opportunities. But on the other hand, then the water system was regulated to provide irrigation there for the big biofuel scheme, and they couldn't do their agriculture anymore because the river was dry. So that was end of story for them. So it's a very complex field of challenges and opportunities with a lot of trade-offs. But I think the simple question is, it takes a lot of land, so it's competing with other uses. So we have to be very careful about that to deploy that. There is potential for biomass, I'm pretty sure, and we can use a lot of it, because now we do a lot of agricultural waste we burn. And we can do it in a better way to get some energy from that, rather than burning it on the field. But you also transport carbon to a different place, and there's a lot of trade-offs that you have to consider to do it wisely. And we too eagerly grab something and go for it without targeting things. At certain places, biomass is wonderful, but not everywhere.
Okay, thank you very much.